What's up, YouTube? And I'm also broadcasting live on Instagram. So again, we're continuing our series today, solving Khan Academy SAT math problems. And I'm doing it again for my parents' house. See all here back here, all my old trophies and random things over there. Instagram, you can see some other random childhood trophies, which is kind of funny. I'm wearing my signed, co-signed Sokotoa t-shirt, just for fun. So without further ado, we're going to get into these SAT practice problems. Again, if you're watching on Instagram, definitely make sure to check out my YouTube channel so you can see the problems actually being solved instead of just me sitting here in my Sokotoa shirt talking about the problem. So without further ado, let's get into it. So today we are doing operations. We're going right down the line, operations with rational expressions. Yesterday we did that guy. Again, I'm seeing these problems for the first time, which is always part of the fun. So let's do it. This is from yesterday. Let's clear the board and let us begin. All right, here we go. First of all, desktop. And we are, I think, this guy. Boom. Let's begin. So we got 2k. So this is just an expression. We got 2k plus over 3k plus 12 plus k plus 7 over k squared plus 4k. And they want to basically simplify this guy. I can tell you right off the bat, my first instinct, as it should yours be, is to factor these denominators as best we can. So I'm going to factor that denominator on the left by pulling out a 3. I can see that 3 is common to both terms. So I'm going to pull out a 3. What do we have left? We're going to have k plus 4. You see how that kind of comes together? We're going to, oh wait, did I hit share screen? You know what? I don't think I did. 1 second, guys. You're still watching my face here. Okay, let's go ahead and do the share screen. Share. All right, now you'll see what I'm talking about. Here we go. Okay, so we got 3k plus 4 in the denominator. And then you see how I pulled the 3 kind of out of this 3 and this 12, right? So we have a 3k plus 4 left. Plus, I'm going to do the same thing over here, but k plus 7 on top. And what can I pull out of there? I can pull out a k out of both terms. K times k plus 4 in the denominator. Now you can see something kind of interesting happen. These two denominators are almost the same. Okay, they both have a k plus 4. They just have, one has a 3 and one has a k. In order to add these fractions, in order to add these guys, we need to have common denominators. So I'm going to multiply this left guy. Since it's missing a k in the denominator, I'm going to multiply the left guy by k over k. K over k is 1. That is allowed. We're always allowed to multiply a fraction by 1. It doesn't change anything. And that will get us what we need on the left side. Over here, it's missing a 4. So I'm going to multiply this guy by 4 over 4. Now, sorry, excuse me, it's missing a 3, not a 4. Let me get rid of that. It's missing a 3 over 3. Now, once we complete this multiplication, this one becomes on top 2k squared, right? The k's multiply each other. And on the bottom, now we've got this really nice 3k times k plus 4 denominator, which is what we were shooting for. Over here, we've got 3 times, well, let's just distribute the 3 to both of these guys, so the k and to the 7. We got 3k plus 21 over, and then we got, again, our nice denominator, 3k times k plus 4. Now we can start to combine these guys. Now the numerators just add, denominators stay the same. That's what we do with fraction. We just, boom, we add them. So again, now we're going to have 2k squared plus 3k plus 21 over, and let's see how they did it here. It looks like they they multiplied it out. I'm going to FOIL this guy because none of these denominators in the answers are factored, and I can see that. So my best bet then is to go ahead and FOIL this guy, distribute this here and here. So this becomes, the denominator becomes 3k squared plus 12k. I mean, like, you can already tell, forget about the numerator, we can already tell from the denominator, they've only got one answer, which is A, that has the denominator we want. Just so happens the numerator matches with this guy too. And so we're in business, we're good to go. So the answer to this guy is A. So I'm going to go ahead and enter that over here. Let's make sure we got this correct. A, and boom. All right, we're good to go. Good work. Again, no calculator section. If you see that no calculator icon, so that tells us if this were to appear on the test, we would not be using calculator, wouldn't be allowed to. And again, remember, these are the best practice questions you will find. You cannot find any better because they're made straight from it's essentially from a partnership between the College Board and Khan Academy. So you can't find questions better than this. This is why I'm using this resource to give you guys good test prep. So let's check this out. Which expression is equivalent to the above for all m is greater than 1, n is greater than 1? All right. Why do they, a lot of people get thrown with these conditions. The only reason why they're saying this is because they don't want to put you in the awkward position of having a 0 denominator, which then throws everything off. When 0 is a denominator, then it becomes an undefined solution. Nothing really makes too much sense with any of these options. That's all they're telling you. You don't have to plug 1 in or 2 in or anything like that. Now we just go ahead and straight up factor this guy. So let's see what we can do. I'm going to say on this numerator, I want to see what I can factor out. So let's look. First, let's look at 49 and 21. Okay. So as we're factoring the numerator, we're just pulling things out one by one that we can pull out of both of these terms. I can pull out a 7, so I'm going to write a 7 here. So then that 49 becomes a 7, right? Because 7 times 7 is 49. And we got a minus here. And then what's left with when you pull a 7 out of 21, you got a 3 left. Okay. Next, let's look at the m's. What can we pull out of both of these terms? I can pull out m to the 4th, right? Because we've got basically m times m times m times m times m here. And then we got the same thing, but 6 m's. So what is the greatest common factor of m to the 4th? M to the 6th is m to the 4th. M to the 4th comes out here. Okay, and what about the n? With the n's, we got an n and an n squared. Greatest common factor of those two is just n. Okay, now what do we have left inside? Actually, this 7 is all we got left in that first term. So let me move this around. We don't need all this space. 7 minus, and then we got 3. It's still m to the 6th is the original term, so we need to have m squared here. Just think about when you FOIL it. When this redistributes back to this guy, the exponents will add, it'll become m to the 6th again. And then we need an n here because when this guy redistributes here, it's going to become n squared. So that makes sense to have just an n left over. And then boom, that's all we got there. And then over 7m squared n to the 4th, I believe. Okay. Now this is pretty cool because look what we can do. We can now start simplifying across the numerator and the denominator. I think Siwa Marta is saying hello. Hello. Thank you for joining. And again, if you guys are watching just me solve these problems, you're not seeing the actual problems, you want to see them, go to my YouTube channel, search for Scalar Learning, and you can follow along as I actually solve this using a whiteboard, solving in real time. I am solving these for the first time, never done it before. So now let's cross simplify. We can do, look, we got a 7 on the top and the bottom. Now you can't simplify within this term into this guy because you have to simplify when you're simplifying across the top and the bottom. It has to be things that are universally applied to the top and universally applied to the bottom. Outside here, it's multiplying the entire numerator. So this is universally applied, this stuff over here. And the denominator is only one term, so we're good to go. These 7s can go away, right? They cancel out. M squared cancels out, it reduces with this guy, but this guy doesn't go away completely. It turns into an m squared, right? We kind of, when we're cross simplifying exponents, we subtract. So we have the higher number on top in this case, so it's 4 minus 2 becomes 2. So we got m squared, and in the ends, we're subtracting up this way because we got the larger exponent in the denominator. This n goes away, and this one turns to n to the 3rd. So let's rewrite it so it's much neater. On top, all we got is m squared times 7 minus 3m squared n over, we got rid of the 7, we got rid of the m squared, all we got is n cubed, right? N cubed on the bottom. I can tell you, without redistributing, doing anything, D has to be our answer. It's the only one with n cubed in the denominator. So it's kind of like the guesswork is done here. If you want, you can simply, all they did to finalize the answers, they redistributed this here and this to here. And they got 7m squared minus 3m to the 4th n over n cubed, right? This guy just multiplies here and then goes and multiplies this term, and then you have exactly what we've got in D. All right, I hope that makes sense. Now I'm going to check it, and yes, we are indeed correct. Excellent. Okay, now getting a little more complicated. Again, you see, like, the name of the game with all this stuff tends to be factoring. It's all about factoring and figuring out how can we simplify, how can we extract different pieces. And that extraction then opens the door up to different processes of like simplification. Okay, let's look at this guy. Again, have to factor. If we don't factor, this is impossible, pretty much. So how can we factor this guy and then start reducing? And why again do they have this k is greater than or equal to 33? It's just going to be in order to make sure that we don't get a zero denominator. I'm betting you. We'll know more when we start simplifying, but I wouldn't worry about this 33 too much. Just start factoring. Okay. Let's first look at our, I'm going to rewrite this. This is a complicated one. So I'm going to rewrite this whole thing out. 4k squared minus 12k. So we have it all nice and neat. 2k squared. And these two are multiplying. That makes life so much easier because it's like it becomes one gigantic fraction once you start factoring all the pieces. You can just cross simplify between both fractions. This is really cool. Plus 19k minus 33. K squared. Now there's also, because I see that one of these, or actually two of these on the left here, they have a coefficient in front of the main term, first term, sorry, the highest degree term. Sometimes we use something called a box method to factor. I'm not going to do that today. They're not that complex where I think I need to show it to you, but it's another option when you're having trouble coming up with the combinations to factor. So let's look at this guy. First, I'm going to do 4k squared. So I'm going to kind of do a little guesswork here. Let's see. It's going to be 4, 3. So it's be 4 and 3 is 12. 12. No, that's not going to work. 4. So I'm trying to figure out what these factors are going to be. So it'd be 4 and 1, and then it'd be 3 and 3 would be 4, 12. Oh wait, maybe I will need the box method. All right, you know what? I'm going to do the box method here. Here's the box method. You go like this. Because we do 2 and 2, 18 and 2. Yeah, it doesn't work. All right, so let's try this. And maybe it's not factorable, but I think it is. Okay, so we have 4k squared up here and the last term down here. Then we multiply those two. We need something that multiplies to 36 and that adds to negative 12. So that would be, so 3 and 12, no, 4 and 9. What else? 2 and 18, no. 1 and 36. Remember, maybe this doesn't work actually. 4, 3, 2, 18. I'm sorry, not 4 and 3. 4 and 9. 4, 9, 5, 6, and 6 and 6. Duh. Yeah, that's why I couldn't think of it. All right, so we have 6, negative 6, and negative 6. Okay, what did I just do? I figured out what multiplied to 36 and adds to negative 12, and it's negative 6. So now with the box method, we found these kind of middle terms here. Why does this help? So let me show you how this works. Now we kind of like factor in this box. Going all the way across in this top row, we see what can we pull out of both of these terms. It looks like we can pull out a 2k, okay? A 2 and a k from both of these guys. So I'm gonna put 2k here. And then what's got to go up here to multiply? See, it's like a big multiplication grid. You really got to be on the YouTube channel to understand what I'm talking about because this is getting complicated. So pop onto my YouTube channel, search for Scalar Learning on YouTube. If you haven't done so yet, you can watch what I'm doing. We have to be, we're going to pull out a 2k on the top. I mean, it's the same idea. What can we extract from both of these two? 2k. And we also see that you sort of multiply the columns and the rows to get what's in here. 2k times 2k is indeed 4k squared. Now, what's going to go over here? What's got to be on top that multiplies this 2k to get a negative 6k? It's going to be negative 3. Same story here. We've now factored this guy effectively. The terms are simply 2k minus 3, one of these rows, or this like side over here, times 2k minus 3, which is this over here. And that's it. I probably didn't even need the box method. I think I just kind of, you know, it got jumbled in my head. I couldn't think of it. But there you go. Now we've perfectly factored this guy. It's actually a perfect square. See if I can do this next one without the box method. Okay. Now we're going to do the guy's denominator. It's a little easier because there's only one way the first term can break down. It's got to be 2k and k. I have a hunch that it's going to be minus 3 and then plus 11. Yeah, and then indeed is right. Okay, minus 3 plus 11. Why did I think that? I thought that because I figured one of these guys would cancel out, but this actually works. Look, 2k times k is 2k squared. That'd be 22k over here and negative 3k. Negative 3k plus 22, of course, gives us our 19. And then we got these guys multiplied at the end to give negative 33. This is hardcore factoring, and that is all good and done. We're going to do the cross-eying out in a second. Let's just factor this denominator. This is pretty easy. We can only pull out a k of those two terms. We got a k minus 3 that's left inside. And now let's factor this numerator. This one's not going to be bad at all. You usually don't need the box method when you have no coefficient in front of that first most significant term. K, you got k. What is it going to be? Can tell you right off the bat. 33 really only has basically one good option, which is 3 and 11 as factors. And those also, if you have a positive 11 and negative 3, those guys add up to 8, which is our middle term up here. Voila, this crazy thing has been factored. Now let's go ahead and cross simplify. Remember, this becomes like one giant fraction because they're multiplying, so simplify any which way. K plus 11, gone. K plus 11, gone. K minus 3, gone. K minus 3, gone. 2k minus 3, gone. 2k minus 3, gone. We're left with such a simple thing. All we got left is 2k minus 3 over k. These are fun when everything lines up like that and you can just go boom, 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 and knock out a bunch of stuff. All right, so this should be our answer is actually A, this guy, right? Clearly, unless we've done something catastrophically wrong. Now let's check it out. Boom, we are good to go. That was only question 3. All right, this is gonna be a longer video. We need to do 4 and 5 still, so let's keep it going. Again, if you're watching on Instagram, go to my YouTube channel, say it again. You can actually see me solving the problems instead of just watching me talk. It'll be much better for you, much more beneficial. All right, here we go. 5m squared plus 7m over 2m minus 9 minus 2m over 2m minus 9. Guess what? This is actually much easier than the last one. Same numerator, same denominator. We can just, boom, go ahead and combine these. So it just becomes 5m squared plus 7m minus 2m all over 2m minus 9. These two terms combined, they're like terms. So now you got 5m squared plus 5m over 2m minus 9. I think that's it. I think it's just B. Because even if you factor this, like there's really nothing else you can do. M squared, 5m times m plus 1. Yeah, there's nothing you can do. So this one was like way easier than question 3, and I believe it's B, unless I've, yeah, I think this should be good. All right, we're good to go. No mistakes. All right, and now we've got this guy here, which they say is a calculator section question. Probably don't need one though. I can sort of have an idea we don't need one when I looked at it. So let's see here. All right, it says 5x over 6y minus 3 over 10y. Which expression to the above is equivalent for all y is greater than 0? Again, y is greater than 0. They're just trying to say that so we don't have to have a 0 in the denominator. That's it. Okay, so let's give it a shot here. We're going to multiply across. This one, again, is actually pretty straightforward. It's 15x over 60. Oh, you know what? No, I shouldn't do it this way. We can do it this way, but I'm not going to do it this way because I want to teach you how to simplify before we multiply. You can cross simplify because it's, again, like one giant fraction. Now look here. If I rewrite this, 5x times 3 over 6y over 10y. Everything is connected when it's multiplying. So this 5 and the 10, we can cross simplify, divide both of those by 5. This becomes 1, this becomes 2. And we can do the same with the 3 and the 6, divide them both by 3, this becomes 1, this becomes 2. Now this is much easier. Now we have 1x on top over 2 times 2, y times y, 4y squared. That should be your answer. And it's the same as D, they just didn't write the 1. But that's it. D's your answer. So D is x over 4y squared. Let's go ahead and enter that and see how that goes. All right, good work. We have done it. Let's go back off of the screen share here. All right. So we're back. So that's it, guys. And I hope that was fun. Sorry, I apologize for my crazy hair. couldn't find my hat, so just went with it. Apologize for my beard. So I'm kind of in Michigan right now, hanging with my parents, and been resting a lot, but had to get up to do this daily broadcast. If you guys are watching on Instagram, again, thank you so much for watching. Next time, definitely check out the YouTube channel, Scalar Learning YouTube channel. You can actually see these problems being solved in real time, and it's a lot of fun. And again, we'll continue with this tomorrow. If you guys need any help or have any questions on the SAT or your SAT preparation, just email me at huzaifa@scalarlearning.com. Would love to hear from you. Thank you guys so much for joining, everybody. See you guys next time. Take it easy.